Hello and welcome to this episode of Mathmeotics. In this episode, we are going to talk about literal equations. What is a literal equation, you might ask? A literal equation is an equation that involves two or more variables. Okay, that means two different variables. And a formula, also one of the vocabularies that may be new, a formula is an equation that states a relationship among specific quantities. Okay, formulas are special types of literal equations. And we know that when we work with literal equations, we can use methods we have learned in talking about one-step and two-step, multi-step, and variables on either side of the equations to isolate any particular variable. Now below I have some examples of some formulas. Okay, these show a specific relationship. The first one we have here is a perimeter of a rectangle. Then we have a circumference of a circle. And the formula for that is the circumference is equal to twice times pi times the radius. C being the circumference and R being the radius. And we also have the area of a rectangle, the area of a triangle, area of a circle, distance traveled, and temperature. So these are formulas that you should be at least somewhat familiar with. You don't necessarily have to memorize them, but you should be familiar with and understand the relationship. Distance travel, that's d is the distance, is equal to the rate times the time, okay, the product of the time. Okay, the temperature, it's a formula given. The temperature is C in Celsius, is equal to 5/9 times F, the Fahrenheit, minus 32. Now, understanding the relationship will allow me to deal things with, like, solve for F. Like I can take just for example, I can take my temperature, and instead of having it to be C equals, I can now solve for F equals. Now there's a couple ways that I can handle this. We discussed before about the properties of multiplication and division. And actually, if I take 5/9 and I multiply it by 9 over 5, what happens? This becomes 1. So, if I multiply this side of my equation by 9 over 5, and I multiply this side of the equation by 9 over 5, I now can rewrite my equation to be 9/5 C is equal to, and then now the 5/9 cancel, F minus 32. That makes solving this equation much easier. Okay, now I can just simply add 32 because we want to isolate the F. We want the F by itself. So the F and the 32 term, they're being subtracted from each other. So I'm going to add, make a zero pair. I'm going to subtract it from both sides, or add it to both sides. Now that's going to give me, now remember, just like normal, I can't combine these two terms. I cannot combine 9/5 C and 32. I can't combine those because the 9/5 C is a variable and the 32 is a constant. So I'm going to rewrite that as 9/5 C plus 32 is equal to F. So now I've rewritten that literal equation in terms of what Fahrenheit, in degrees Fahrenheit, is equal to. The degrees Fahrenheit is 9/5 times C plus 32. Now, I want to comment about this 9/5. That's the same thing as saying 9C over 5. These are equivalent statements. Okay? Because that's essentially C over 1. And if we have C over 1, that's 9C over 5. Okay? Now, let's get further. Let's talk about an actual problem. All right. Now, problem number 1, it says we're going to rewrite this literal equation. Now, it gives us the equation 10x plus 5y is equal to 80, where x is the number of pizzas and y is the number of sandwiches. Now, we want to know, oops. We want to know our goal. Let me write goal. That's going to be easier. So our goal is how many sandwiches, put sandwiches, I'm just going to put SW for sandwiches. When we have 3 pizzas. So I'm going to put 3P. Or how many sandwiches when we have 6P. Okay? 6 pizzas. I'm going to put pizzas. All right. Now, X is the number of pizzas. So we know X is the number of pizzas. And we know Y is the number of sandwiches. Okay? We're given the equation. So that means 10 times the number of the pizzas and 5 times the number of sandwiches will give us our total, which is 80. Okay? $80. Essentially, we have $80. This is most likely what we're looking at as their budget. Okay? Now, the easiest way, because we're talking about how many pizzas, the easiest way for us to handle this is to solve the equation in terms for y. Because I'll show you. You can solve it the normal way. We could just plug in our values and solve. But we want to know what any value that we have in pizza. I could find the number of pizzas for 1, 2, 3, and how many sandwiches that we're going to get. Okay? So now I'm going to take my equation. I'm going to erase some of this so we have room. And I want to isolate the y by itself. Okay? Well, I have 2 terms in this expression, so I'm going to move one of the 2 terms. Well, just like we have a normal equation, I'm going to move the 10x from both sides because I want the 5y term by itself. I want that variable to be by itself. So that's going to cancel that out. So then I'm left with 5y is equal to, that's going to end up being 80 minus 10x. Now I want to make it this comment here too. This equation is equivalent to 5y is equal to negative 10x plus 80. As long as you keep this sign, the signs correct, the commutative properties of algebra says that the order of these 2 terms does not matter. Okay? Now, I've almost got y by itself. Well, now, in order for me, they're a product. So 5 times y, that's a product or multiplication. So I'm going to divide by 5. I'm also going to divide this whole side by 5. Okay? So that's going to be y is equal to, now that means I can split these up. So that would be 80 over 5 minus 10x over 5. Now, correct property says that we reduce. So this is going to be y is equal to 80 divided by 5. It's going to give us 16 minus 10 divided by 5, which will give us 2x. Now, we solved it in terms for y. Okay? That means y is our sandwiches. So sandwiches equals 16 minus 2, whatever the value of the pizza is. So we said that we wanted 3 pizzas. So we're going to plug that into our equation, or substitute would be the correct value. So we're going to say y is equal to 16 minus 2 times, we wanted 3, which that's going to give 16 minus, or 2 times 3 is 6. So 16 minus 6 will give us 10. So we can buy 10 sandwiches. So we can buy, not B-Y, B-U-Y. 10 sandwiches when we buy 3 pizzas. Okay? Now we also want to find out how many we can buy when we have 6 pizzas. So that's going to be y is equal to 16 minus 2 times 6 is equal to 2 times 6 is, or 2 times 6 is 12. So 16 minus 12 will give us 4. So when we buy 6 pizza, we can only buy 4 sandwiches. So we can buy 4 sandwiches. I'm just going to put SW when we get 6 pizzas. I'm just going to put Zaz. Okay? And that is our answer for both of those questions. All right. Now let's look at problem number 2. Actually, I'll go on problem number 2 in the next video. I don't want this to get too overlong. I'll see you later.